Goedendag, willkommen in einem anderen Figurenspiel video. Welcome to yet another exciting video in my figure gaming series. In this case, it is a redone version of an older video, in which case where I discuss painting 6mm figures and some of the optical illusions you'll need to consider when doing so. This video specifically covers painting 6mm micro-arm figures. Many of the rules here do not apply to larger scales. This video will not cover painting techniques. Instead, it's really focusing on arriving at the correct colour or optimal colour for your 6mm figures. One of the issues I had when painting 6mm figures was that colours always ended up being too dark if I used the historically correct colour. I went down the historically correct path because when I purchased a paint which the manufacturer claimed was correct, and then I looked at it, I felt it was far too light. I simply assumed the manufacturer of the paint did not know what they were doing or made an error. But as it turned out later, they did actually get it right and I got it wrong. I discovered that colour changes based on the distance you are from the object. The way the eye perceives colour varies a great deal based on the distance the eye is from the object. When looking at a medium tank, in order to see the entire vehicle, you may decide to stand back from it, such as 10 metres. I'm talking about a real tank, not a figure. On the other hand, when we're looking at a 6mm figure, we're often much closer to it, possibly 20 to 30 centimetres, and certainly no more than 1 metre. The difference in distance has a major impact on the perceived colour. A good way to demonstrate this is to use some dark coloured paper or cardboard and cut a 3cm square and a 9cm square. Place the 3cm square piece 1 foot from the edge of a table, standing it up so you can look at it from the table edge, and then do the same with the 9cm square, but place it 3 feet from the edge. Line it up so when you are looking from the edge of the table, you can see both squares next to each other, and they should be apparently the same size. You will quickly notice the 9cm square is lighter. Using this information, let's look at some manufacturers' paints. The colours shown here are supposed to represent Russian World War II protective green, or AMT4. You will notice a large difference between the colours, which has always puzzled me. My assumption is Tamiya is providing the correct colour on the left, while Mr. Hobby is factoring in the fact that you are using it for a smaller model and thus it's lighter. To make things worse, the opposite occurs when you're dealing with light colours, so white never looks pure white from a distance. The model train community has known about this effect for many years and have a wide range of formulas they use to get the correct colours for their trains. One simple formula is when painting a 1 in 76 scale model, you need to mix 15% matte white into the paint. If it's 1 to 48 scale, the number drops to 5%. In the other direction, I have no idea what the formula that they use, but clearly the ratio is not linear. Let's look at a 15% lighting effect. On the left is the supposed correct colour, that is, it's the correct protective green RGB values depicted on the screen. On the right is the correct colour that we assume the Russians physically painted on their tanks, mixed with 15% matte white. You can see a significant difference, and on first impression, the colour on the right feels like the correct colour to use for Russian tanks. In the centre is a coloured photo of a Russian tank. I must point out coloured photos rarely show the correct colours, so do not focus on the colour too much. Instead, focus on its apparent lightness or darkness. And what you can see is the colour on the right is closer to the actual colour. The box under the tank is my estimation of the apparent colour of the tank, and while its RGB values may differ, the apparent darkness is perfect. I suspect the RGB values of the best section of the tank colour will give us the correct value, and that's actually what I used. I inspected the spot on the vehicle which looked most pristine and got its RGB values. If you went right up to the Russian tank and looked at a 3 centimetre square, the colour would be closer to the colour on the left. I estimate the camera is about 5 metres from this tank, which means if you were 65 centimetres away from a 1 in 76 scale model, the colour would be correct. As I map out this distance from my screen, it does look reasonably correct. There is a lot of assumptions here, and this feels like it's correct for a 1 in 176 scale model, and possibly even other scales with additional modification. Let's look at another range of paints, MIG paints, which are designed to be used with 15mm figures. While the colour itself looks wrong, which could be an effect of the coloured picture, the darkness is a lot closer to Tamiya. I'm certain photos give you the wrong colours because I have a bottle of protective green with me now, and it looks a lot like my estimate, the correct estimate for the colour of a Russian protective green. Now we have another bit of complexity to deal with, the thickness of the paint. I normally water down my paints to give my figures contrast. This way, the bit which sticks up are a bit lighter than the bits which are embedded in the figure. This has the effect of lightening up the paint, although even using this technique, the colour is still too dark. Based on this example, the best choice would be Tamiya NATO Green, which I must admit I have heard other gamers state is the best colour for Russian tanks, World War II as well. Mixing white with your Tamiya dark green is the actual closest, and while MIG is not, here, MIG 23 protective green looks very close to this as well, and it's probably the best colour to use if you use a spray gun, not a dry brush. My formula, derived from Rail Hobbiness, was designed for 1 in 76 scale, which I think is 28mm. This seems to feel correct, and the formula does change with scale. So what should we do about the difference between, let's say, 28mm and 6mm? My gut feel is if you dilute your paint with water to get the effect I mentioned earlier, you get a sufficient lightening effect to compensate for the scale difference. We also need to remember the effect is not based on the scale of the actual figure, but on the distance you view it. My railway formula is based on viewing the model from 60 centimetre away, which is a distance you may also view 6mm fig. 30 centimetres is possibly the closest you would get, so the lightening effect does not need to be as great as you would expect. At least that's my opinion. I could be totally wrong, and we would need to continue the lightening effect if we want it to be technically correct. If we go with 30% matte paint, white, the colours are as shown here. This could be correct, but it does seem a bit light for me. The 30% figure is based on halving the viewing distance, which again is another wild guess on my part. The railway community claims the light colours need to be darkened, but provide no values that I could find. I need to understand why the colours change, and my only guess is it's affected by the average lighting conditions you are viewing in. Most people sit in an environment which has colours all around them, which has the effect of darkening everything. Photographers normally use the 22% grey sheet to reflect light to get a natural effect. So I'm assuming we live in a 22% darkened world. Assuming that makes any kind of sense. If this is correct, then when an apparent colour darkness drops below 22%, from a distance it will look darker. This is because the background 22% is merging in with the actual object's lightness, or ability to reflect light. So white, which has an RGB value of 255, 255, 255, would look 22% darker over some unknown distance. If we use our 15% estimate, we need to mix our background colour into the actual colour on the ratio of 15% to 85%. On the left is pure white, and on the right is our white mixed in with this supposed background grey. The right is supposedly the whites that we view from a distance in the real world. This does seem reasonable, and you can actually test this with the table edge experiment which I mentioned earlier. As I lack a table which is 5 metres in length, I had to extrapolate, but the whites were darker over a distance. If my theory is correct, then there is no change in colour by distance when the colour that you're looking at has an overall darkness of 22%. If we look at the German dark yellow or dunkelgelb, we can estimate that its black and white darkness is 150, 150, 150. This is greater than our background value. So how would it be affected when we factor in the background value? As you can see, there is a slight lightening effect, but it's not very great. If we look at Tamiya dark yellow, which is darker and possibly the correct German dark yellow colour, using Mr. Hobby may give you the correct level of lighting effect. In summary, the distance effect is greater for darker colours and much less for lighter colours that approach this magic 22% in average lighting condition. Obviously, if you live in the north of Germany, where the background light is a lot less than 22%, it'll be different from, let's say, the mountains of Bavaria, where there's a lot more light. For my final calculation, I'll be using the Tamiya dark yellow, as I suspect Tamiya provides a colour which is closest to the real colour used by the Germans, but of course over distance it's not correct. Based on my grand theory summary, the formula is as follows. The background light varies. It's darker when lighting conditions are poor and lighter when lighting conditions are brighter. I'm using a photographer's 22% background, but as an example, in the desert condition, it would be much less. When we view an object at 5 meters, I think about 20% more of the background light mixes in with the color of the object than if we viewed it from 60 centimeters. The reason why this is 20% instead of 15% is the example which uses 15% mixed in is pure white. In this example, we are mixing in the background color which is not pure white, so some maths need to be done, which you can do in a spreadsheet if you so desire. Players can create a formula for this, but using RGB values only gives you a starting position. Due to the wide variables associated with real paint, you would need to test it to verify if the colour is correct, but I suspect this is a good starting point. Using my original example with Russian Protective Green, we arrived at the following result. The colour I will use for the Russians is NATO Green from Tamiya. Based on my information, the British-based colour is the same as the Russians. I find this rather odd and feel the British should be a touch darker, so I may try the slightly darker Mr. Hobby H302. But first I will test this idea on my Russians. I have no idea if my formula is correct or not, and I did test it. In the past, my Russians and British figures were simply too dark, and I corrected it and they look a lot better. The Germans, on the other hand, because I used a can of paint which said it was the correct colour, dark yellow, seemed to look okay. Let's look at some examples from the GHQ website. I personally think these figures look great. They all look lighter than my estimated green colour, but as we discussed, my estimate is based on 1 in 76 scale figures. When we go down to 6mm, we need to lighten the paint and thin it out. This looks like it's been thinned out and lightened, so I think I am on the correct track. The more I investigated this topic, the more I began to realise that the effect of distance, that is the colour effect over distance, for 6mm figures, or getting it correct, is far harder than 15mm figures or larger scales. When I originally went down this path, I thought I could find the perfect historical colour for my 6mm figures. In the end, the complexity is simply too great. I strongly advise gamers to simply use the paint manufacturer's suggested colours. You'll never get it 100% right, but it'll be close enough. After all, when all the figures are in the playing area, it's not as if you'll notice that the RGB value of a particular figure is slightly off or correct. The final solution I adopted was I searched for as many paint guides as I could in order to determine the colours to use. While the major nations are reasonably simple, I found it rather difficult to get the correct colours for other nations, such as the French. This is my estimate for the colours which should be used for the French 1940. This is my painting guide for the Polish 1939 vehicles and troops. I've discovered using this system is far easier and gets a much better result than trying to mathematically calculate the exact RGB values of the historical paint and then try and build in the effect of scale. And so we come to an end of my part 7 of my figure gaming series of videos, in this case an overview of painting 6mm figures. Alle guten Dinge kommen zu einem Ende.